Friends, this video is the continuation of our previous video. So how to find the transition matrix. Okay, here they give the two bases. One is alpha, is a standard basis for R2. So beta is another basis. It is rotating the standard basis only, some counterclockwise direction, so angle by theta. So first of all, they didn't give the explicitly what is the E1 prime and E2 prime. Our first aim is I want to find what is the E1 prime and E2 prime, but I know what is the standard basis, correct? So using that we are going to deal. So first start with the solution. So alpha is standard basis. So standard base means E1, E2. Correct. So this E1 means the first component is 1, remaining part is 0. E2 means first part, remaining second part is 1, remaining all other components are 0. This is my alpha. So they are telling that it's rotating the angle by theta. So I want to first I will draw the graph to understand it. Correct. First step I will take the this is my so I will take this is as 1 comma 0 comma 0, and this is the another 0 comma 1 I will consider. Okay, so now they define the new vector. This is, so I will take it, this is the vector. So this is the vector E1, this is the vector E2, this is the vector E1. Now they define the E1 by rotate by the angle theta, that is my E1 prime. So I define the E1 prime. So this is my E1 prime rotated by the E1 by the angle theta. Similarly, E2 also rotation by theta only, correct? This is the angle theta. This is I called as a U2 prime. I want to find what is the E1 prime and E2 prime. First I want to find E1 prime. So I will make it as this point is I taken as some, suppose E1 prime is I don't know, so directly, so I will take as E1 prime equal to some x comma y. So I want to find it. So this is the prime. So what does it mean? This is my x, this vertical line is my y. So it forms a right angle triangle. So sin theta equal to, so this is sin theta equal to opposite side by hypotenuse. So I know the length of the vector is 1 because I am not any magnify, I simply rotate the standard basis. So length is always 1. So y divided by 1, this implies y equal to sin theta. Now similarly I want to make the cos theta equal to x divided by 1, this implies x equal to cos theta. So then we can find what is the E1 prime. This together implies E1 prime equal to cos theta comma sin theta. Secondly, I want to find the E2 prime. So here also I want to make the right angle triangle. So here the thing, this point is I will take as minus x comma y because this is the negative direction, that's why, but this length is always x. This length is positive only, so I will take as a y. So you please find it. So cos theta, sin theta equal to, opposite side is minus x divided by 1. This implies, sorry, here my not minus, the length is always positive only, correct? This length is always positive, length is x only, x divided by 1 equal to sin theta. So x equal to sin theta. But my E2 prime is what? E2 prime is minus x comma y. So this implies minus x equal to minus sin theta. Similarly, cos theta is directly y divided by 1. Because this is the theta, y is adjacent side by divided by hypotenuse. Here also length is always 1. So y divided by 1, this implies y equal to cos theta. So this implies my E2 prime is minus sin theta comma cos theta. So now find that what is the beta. Beta is my E1 prime and E2 prime. That is my beta is cos theta comma sin theta minus sin theta comma cos theta. This is my beta. So I want to find what is the transition matrix of alpha to beta. So my aim is I want to find what is the ID alpha to beta. So domain space is alpha only. So that meaning is I of E1 in the one vector in the beta, I of E2 from beta. So I of 1 comma 0. So here identity element, ID of 1 comma 0 is 1 comma 0 only. So A11 times cos theta comma sin theta plus A21 is cos minus sin theta cos theta. So this is the system of equation. You will get it as A11 cos theta plus A21 minus sin theta. So I will write the minus here to 1. Sin theta equal to 1. A11 sin theta plus A22 cos theta equal to 0. So this guy is I can represent in terms of cos theta minus sin theta cos theta times A11 A21 times equal to 1 0. So I clearly know that this is the orthogonal matrix. So I can find the inverse is their transpose. So transpose you will get, it means that is your inverse. So A11 A21 equal to, I multiply the transpose both sides. So I will get the transpose is cos theta sin theta minus sin theta cos theta multiplied by 1 0. So you will get it as A11 equal to cos theta, A21 equal to minus sin theta. Now similarly, this is my ID of 1, 0. Their coordinate vector in beta is cos theta minus sin theta. Now similarly, I want to find ID of 0, 1 equal to 0, 1 equal A12 times cos theta, sin theta plus A22 minus sin theta cos theta. The same way only your right hand side, that 1 0 will change to 0 1, remaining everything is the same only. So you will get it as cos theta minus sin theta cos theta times A12 equal to 0 1. So the previous argument what we done, this is the orthogonal matrix. So inverse is orthonormal matrix. So inverse is simply its transpose. So okay. So this implies A12 A22 equal to cos theta minus sin theta cos theta. So you multiply 0 1, we will get it as A12 A22 is sin theta cos theta. So ID alpha 0, 1 in terms of beta equal to sin theta cos theta. So my matrix representation ID alpha to beta is ID E1 coordinate vector in terms of beta ID E1 coordinate vector of E2 beta. So this is nothing but cos theta minus sin theta cos theta. So here we are converting the basis from alpha to beta. This is the transition matrix. So transition matrix, clearly we read T transition matrix from alpha to beta or coordinate change matrix from alpha to beta. I hope this example clarifies how to find the transition matrix from alpha to beta or coordinate change matrix from alpha to beta. Thank you for watching this video.